In this video, we are going to find trig function values of any angle in standard position. So an angle in standard position that has the vertex at the origin, and so we can always draw a right triangle from whatever point there is, and so the radius of that circle, because x would be one side of the right triangle, y would be the other. Using Pythagorean theorem, we get x squared plus y squared equals r squared, and then taking the square root of both sides, that's where we get r is equal to the square root of x squared plus y squared. And then we have our trig functions defined here in terms of y over r for sine theta, x over r for cosine theta, y over x for tangent theta. And then we have our reciprocal functions, cosecant, secant, and cotangent. In example 1, we have the point negative or positive square root of 2, and the y value is negative square root of 14. It lies on the terminal side of an angle in standard position. Okay, in standard position, our point, I'm going to just kind of estimate it. We have a positive x and a negative y, so we're in quadrant 4. And our point is at square root of 2 for x and negative square root of 14 for y. So I can draw my right triangle. The radius is going to be equal to the square root of x, which in this case is square root of 2, quantity squared, plus y, which is negative square root of 14, quantity squared. So we get square root of 2, quantity squared gives us square root of 4, which simplifies to 2. And then negative square root of 14, quantity squared, is negative square root of 14 times negative square root of 14, which is a positive square root of 196, which simplifies to 14. And so our radius is square root of 16, which is 4. Great, now we're all set. We are ready to evaluate cosecant of our angle theta. So cosecant is defined as r over y. R we just found is 4, y is negative square root of 14. Now we do need to rationalize the denominator, so we need to get rid of that radical, that square root of 14 down there. We do that by multiplying the numerator and denominator by square root of 14. And then we get negative square root of 14 times positive square root of 14. That would be negative square root of 196, which simplifies to 14. And then one final little step, just because 4 and 14 are both even, we can simplify that fraction just a tiny bit more. And so that would give us 2 square root of 14 over negative 7, but we can just make that whole fraction negative. So we get negative 2 square root of 14 all over 7. All right, good. Next one, secant of theta, and that is defined as r over x. Our r is 4, our x is square root of 2. And rationalizing that denominator, we get 4 times square root of 2 all over square root of 4, which simplifies to 2. And then just simplify that fraction. 4 divided by 2 gives us 2 times the square root of 2. Good. All right, and last one, we need to find cotangent of theta. And cotangent is defined as x over y. So our x is square root of 2, our y is negative square root of 14. So now we're going to rationalize the denominator. Multiply the numerator and denominator by square root of 14. And if you have two radicals being multiplied, those get to come and get multiplied within your radical. So we'd have square root of 2 times 14. In the denominator, we would have square root of 14 times square root of 14, which simplifies to 14. Let's see, this would be square root of 28. But 28 is the same thing as 4 times 7, so that could be written as square root of 4 times square root of 7, and then the square root of 4, that can simplify to 2, so we would get 2 times the square root of 7. up in that numerator. Okay, so the numerator becomes 2 times square root of 7 all over negative 14. We can make the whole fraction negative. And then we have even 2 and 14, so we can simplify that fraction. Final step would be square root of 7, and since 2 goes into 14 7 times, and the whole fraction is negative. Done and done.